Hello everyone, welcome back to our architecture series. Today I will be talking about problem framing, which is nothing more than to understand the problem before evaluating options. Meaning that sometimes when we are in a meeting and someone challenges or says something about, okay, we are having these issues, we automatically try to give a solution. But most of the times these solutions are not the correct ones because we didn't start yet to frame it. We don't understand well what is the issue, and sometimes we jump with things that I know a tool that does something. Maybe we should apply this pattern. Maybe we should have kind of a Kafka event source thing. We have a lot of solutions that pop in our mind, and that's wrong because we need to understand first the problem, which is framing the problem. So in this video, I will be presenting you what is problem framing, what are the common flows versus architecture flow. We go deep dive in problem framing framework, which is a kind of a 7-step approach to all look into a problem. And at the end, we should have at least a good solution that it's based on facts. Okay, and we will see later some simple use case, a big use case, and some simple use case, so we can understand better how to approach this problem. It's not at the end of this video you'll be an expert in framing the framework, but at least it will, I would say that it will bring you some awareness about it, and I hope that the next time you have a challenge, you stop and think and use this kind of a framework to approach it, and I'm sure that you'll be better architect, better software engineering, maybe just an engineer that wants to be an architect. And that's one of the objectives of my videos about architecture. So let's start about this. So what is the cost of premature solution? Imagine that you have a challenge, a problem, and usually there are things that pop right away. And something like moving to microservices without domain modeling. Sometimes you say, okay, a good solution for this, and I see this a lot. This is not just about this video. I see this a lot on my personal experience, that people say, okay, microservices is the trend, we should go with microservices. But when I start to talk with people, they don't understand what is domain modeling. So they have it's difficult for them to understand what will be the domain, what will be the scope of the microservice. And then if they don't understand the scope of microservice, how can they implement an architecture, a microservice architecture? That would be quite challenge. Or other times, since in the past people were using something like message queues, Java, which was called Java messaging system, things like that. Now the trend is using Kafka, but sometimes people just use Kafka just for a few, and when I say few, just 1 or 2 thousands of events per day, something more, maybe a queue, even a table in the database. Sometimes it's enough, as I will show you later in this video. And Kubernetes, everyone is talking about Kubernetes. Everyone that wants to be an architect takes a course or certifications about Kubernetes. But Kubernetes, it's not something that you should know or you should manage. Usually it's a team of people. It's very difficult for just 1 or 2 persons to handle Kubernetes infrastructure. And Kubernetes infrastructure, it's about a declarative approach. And usually if the people that learn Kubernetes just choose to use Kubernetes in a company, that can be a big issue. Because if they don't have at least good experience in DevOps, they should understand all the processes, because the Kubernetes is a kind of a declarative framework. It's not something that you do, it's something that you define, and Kubernetes by itself will manage your system. So it requires you some sensibility and experience in DevOps. This is just real examples, and I see this every time. What will be the impact? Technical debt, because if you don't know quite well how to work with these technologies, and this is just 3 examples, there are a lot of other examples that I can give you. Of course, you will have technical debt, something that you, at the end of the day, is something that you will pay in the future. Your ignorance now will be a kind of a cost in the future. And then you have systems that are misaligned. Maybe you took these decisions to use Kafka, Kubernetes, or things like that, and your company already has some know-how and already has some architecture in place. And at some point you start to create a kind of a mushrooms there that are not aligned with the others. And that will complicate the life for the developers, architects, DevOps people, support people, everyone. Even the business people will start to be a little confused about the systems. And of course, this is about people. People earn money monthly or weekly, depending on the country. So there will be costs on that. And of course, it's something that will happen. I see this a lot in big companies, rewrites within 6 to 12 months. Every time I go to a bank or a big company, they are always refactoring something. But probably it was bad decisions in the past that lead to technical debt. The systems are not aligned and something looks into it and say, okay, maybe we should fix this. That's one of the problems. So it's the cost of a premature solution, meaning that people went quite fast to a solution without thinking first what will be the approach. It's not that you get the complete approach, but maybe a step by step, as you will see in a moment. So why do people jump to solutions? First, we have to think in the psychology of the human, that because at the end of the day are humans managing this. And it's something that I always bring in the meetings where the companies I work is that we are all humans, and most of the time the problem is the human factor. It's not the technical factor. There are a lot of languages, a lot of solutions that you can use, but at the end of the day it's just people. So the first is the cognitive bias. This is a lot. If you went to college, probably it's one of the things that sometimes they talk. It's the cognitive bias. If you go into psychology, sociology, any kind of book, they always bring as one of the first topics cognitive bias, which is I know this tool. It's like politicians. I know how to manage a country. I know how to manage this finance and things like that because they have this experience. So they will use those tools, even if they are not the best ones, but it's the tool they know. Okay, so a developer defaults to familiar stacks like React or Kafka without evaluating it. They are fit for purpose, meaning it's in our trait to say, okay, I know a lot about this stuff, so I will use this stuff. Maybe it's not the right approach from the company. And for a developer, I understand. For a software engineer with some experience, I somehow understand. But then an architect, it's a no-go. It's the first thing that you should remove from your mind. It's a cognitive bias. You should always look into the perspective of the company, not yours. Even if you don't know a technology, but you do an analysis and you think he is the best, take some training, talk with people that you maybe hire someone for a few weeks or months to help you to implement that, because at the end of the day, it's your responsibility to build a good architecture for your company and not for your own ego. That's one of the best advice that I can give you. And if you want to be a successful architect, think about your company and align with their business, not with your interests, your agenda, or your career, let's say like this. And I'm sorry to be really blunt about this, but I learned this. It took a while for me to learn this because we have our proud, we want our career, we want to show that you know about stuff. But when someone hires an architect, it's not because it's high skilled, it's a high technical manager. It doesn't mean that he has to know everything, but he should know how to manage everything about technical aspects. So remember this, maybe this is one of the 2 minutes talk that I give on my videos that will be the most important for you if you want to be an architect. So pressure to deliver fast, teams are rewarded for speed, not depth, leading to band-aid solutions. I see this a lot. People want to be fast to implement, to show that they can do it and things like that. That's the wrong approach always. Go small, but let's say efficient, and it works. That's people want, even if it's a small increment, people want to understand that something is growing, something is going towards the goal. Okay. Result-driven development, meaning choices are made to impress peers or future employers, not solve the actual problem. This is a lot in juniors. If you are managing juniors, look for this. And if there are people that want to make a career, you will see a lot of this. So it's always a challenge to manage these people, but they are everywhere. Probably I was one of these people. When I start, when we start to understand a few languages and they start to look to understand some patterns, at some point we want to impress that we know this stuff, but with time we start to understand that we don't know nothing about it. Fear of looking indecisive, quick choice appear confident even when they are misinformed or rushed. I took a lot of years to understand this, but today I don't rush into decisions. I always think I will think about it. like give me 1, 2 or 3 days. I will think about solutions. Then you present your solutions. You present what is good, what is bad, and people will build more trust in you when you have this way of working, because you will be considering and showing to them that, okay, I didn't have an answer 3 days ago because there are a lot to think about, and I have to think about everything that was exposed there. I had to do more questions about it, and now I can show you what are the trade-offs. So there is one solution, second solution, third solution. These are the trade-offs. The best one is great for this, but it's bad for this. The second one, and so on and so on. So don't fear of looking indices. Indices, it doesn't mean that you don't know. It's just just show the people that you are in the season, not because you don't know, but because you want to be careful about your decision, because it's an important decision for your company. And of course, misunderstanding the architectural, that's what I've been talking about. Some assume it's about picking tools. It's not about align the size, design and deeper goals. And I think you understand after I talk about these first 4 points that all of them lead to this fifth point. Okay, so what is problem framing, which is the subject of this video? Okay, first you have a kind of the discipline of understanding the problem fully before evaluating solutions, meaning that you have a problem, gather as much information, follow some steps to understand what is the real issue, because you want to resolve the real issue. And I'm not talking about bug. Maybe it's the system is not responding well. It's becoming so slow. It's degrading. So it's you have to understand what is, because you want to resolve this. There is no universal solution. There is not the solution. That doesn't exist in real life and in real architecture. So it's really, really important for you to understand or to frame the problem. If you frame the problem, you understand the scope, and then you target the solution for this problem, not to suppose future problems that can appear. So usually you have a problem space and want to reach the solution space, and a lot of steps that are in the middle, that I hope you understand them and try to apply them. It's not a scientific approach, but you can somehow follow a kind of scientific steps that can help you, at least as a guidance. So the first thing that you should do is to discover what are the symptoms. Maybe you need metrics, logs. Maybe you have to change to change the system to discover more information. Sometimes the first step is, I will change the system. I don't have a solution, but I need to gather data. Maybe I need 2 or 3 days. I will ask people to add more metrics, add more logs. I want to check this and this system, things like that. So you want to understand the symptoms. Then you have to understand the stakeholders. Who are the stakeholders involved in this? It's the end customers. It's the business. It's employees inside who will feel more the problems that arise with this issue, for instance. And what are the constraints? There are always constraints: money, people, technology, government laws, and things like that. And you have to understand them. So you can see from these 3 points that you are framing something: the constraints and stakeholders. And the systems will gather information, but stakeholders and constraints will help you to create the starting frame for it. Then you define what is the real problem. Okay, now I understand the problem. We are having issues. Sometimes some checkouts fail, and we don't understand why, for instance. And again, you define the constraints about this. Okay, maybe it's a performance, maybe it's a CPU, maybe it's a lot of things, and you want to define that. Then you develop options, not develop the code. So you say, what are the options here? What can we do? How can we do? Do we need to discover more, or maybe we need to develop something about what the framed problem that we came out. So what are the trade-offs for each one of these solutions? I have a solution 1, 2, 3, 4, but one has impact here, the other is one takes 1 month, one takes 3 months, one requires additional people, one requires to buy a system. There are a lot of things that we can create even some prototypes. Okay, we cannot change the architecture now, but you create a prototype, and we can shadow this prototype. It's something that we'll talk later in this video. It says sometimes you have a system, and at the same time you build parts of the system as a kind of a shadow. It means that they are working, but it's not in real production. Meaning, if imagine that you want to test a kind of event source, so you send the data to a table, but at the same time you send something to an event queue, and you see what happens, and you start to detect that sometimes in the table it starts to fail because it's synchronous. And on the other side, it always works, or the the issues are less than the other ones. So you are shadowing, and then later you say, okay, maybe the solution is go to the event source. So I will redefine my application to target the other one. And what is a great thing, it's because you were shadowing, you can already move quite fast to the other solution. Okay, that's something that we can do. That's the prototypes that you can create, for instance. And then, of course, you deliver if you already framed the problem, you already decide between the options what is the best one. So you make sure that the solution is aligned with the real need. Again, the solution is aligned to the real need, not to suppose needs that will be necessary in the future. It's the need now. And we will align a solution for this need because we want to measure it. We want to monitor. So, and we should see an improvement. If you are addressing something that can happen, how do you measure that? Because it's not happening, right? So, and of course, it will deliver business value. There is always a value behind it. If you are not gaining money or not improving, that we are not losing money, so there is no reason for you to change your system. So let's see some common flows compared with the architect flows. So common, let's say bad, it is quite usual to see that. Receive vague business requests. This is really, really popular. And of course, the architect should make sure that it framed the real business and technical problem. And I'm creating some videos. In some of these, I already talk about that. We have to talk with stakeholders. We have to talk with them and understand better. Don't start without be clear with them. What is the requirement? What is the pain? What are they really trying to solve? Assume requirements are well defined. They are never well defined, never, because they are just ideas and intentions from people that they know what they want. Maybe they want a result, but they don't understand everything, the attributes, what is possible, what is not, something about privacy of data and things like that. Of course, the architect flow should understand the constraints and the systemic forces. There are a lot of things against some of the requirements. Okay, choose a technology stack prematurely. People say, okay, React is great. I don't like Angular. Kafka, it's better for event source. I don't want message queues. And sometimes a table, it's enough. Let's go to the cloud. Everyone is going to the cloud. It's best, really. And do we have people for that? Do we have knowledge for that? Can the data go to the cloud because it's private data? There are a lot of things. So involve stakeholders early to clarify expectations. Okay, make sure that your technology stack will align stakeholders. And stakeholders is not only the customers, are also your managers, developers, everyone that works in a company. Okay, start implementation based on assumptions. Never do that. You will create technical debt for sure. Never do that. Don't assume nothing. As an architect, never. Just ask. Make sure that someone will tell you. The business analyst, product owner, someone from the management, some survey that you do, always have facts and data to prove your decisions. Otherwise, it's just an assumption, and if something goes wrong, it's your fault. It's as simple as that. So explore multiple solution paths and show them to the stakeholders and decide with one of them. Realize too late the solution doesn't solve the actual problem. This is kind of a corollary of the things that I said earlier. So choose the best fit based on clear trade-offs, clear negotiation, clear communication, and so on, and accumulate technical and strategic debt. This happens every time from the developer point of view, architecture point of view, due to a lot of issues. Time, there are a lot of reasons to create technical debt. It's not bad to create technical debt per se, if you can measure it. And sometimes I ask people, but it's very difficult for people to understand that. When you are doing something and you did a trade-off and you know that you are losing something, create a user story, create a task and put it on your backlog, say, this should be addressed in the future. And in the future, you will look into it and say, we have 20 tasks about this. It can take 3 months to resolve this. This is the money that we'll spend in the future. This is the cost of the bad decisions in the past. Okay, and you can negotiate this for your next decisions, or you want to say something that it's better for the company, but the stakeholders are not accepting. Maybe you can show this list of time and tasks that should be there. So align implementation with framed goals. That's the architecture flow. So I will show you now this framework about how to resolve this kind of problems, or to help you to resolve the problems. It will not resolve the problems, it will give you a kind of process that you can follow And if you follow this process, I won't say that it's guaranteed, but at least you have a path, you have a kind of a plan or a strategy to resolve an issue. I would say that you have a plan. Strategy is a little bit different than tactics. It's a plan, and then you create strategies to implement your plan. It's a 7-step framework. So the first, of course, it's a problem description. Then you have the business drivers. This is all important in architecture. Then you need metrics to understand if the success or not. So in your project, what is to be successful? Okay, technical constraints. Okay, one team plus here. Sorry for that. Some system forces, they're always in all projects, but I will explain in detail each one in a moment. Stakeholders and boundaries. Stakeholders and business drivers are the most important thing in every architecture. And of course, the latest one, that is one that you want to reach, is a solution hypothesis. So let's start with the problem description. It's what observable issues or pain points exist. It's always about pain points. Money that we want, something that is occurring in our system, maybe it's the degradation, maybe it's something that is failing, and so on and so on. When did the problem first surface and what has changed since? We want to understand what is the behavior from the start to now. Are degrading more or just something that it's cycle? This is important to understand that. What is the impact on users, on operations? This is really important because if it's the users are the end users, customers, you can guess that it's not only about money, but the image of the company to the outside. Okay, are these symptoms or root causes? And this is really important. Sometimes it's not easy to identify the root cause. So you have observable issues, what is happening. You have a timeline. That's the second step, impact on user operations. And you have to decide root versus symptoms. Are we treating signs or causes? This is what we want to address. We want to remove quite away the symptoms because it's causing us something bad. And later we treat the root cause, or we go with a different strategy. But you have to understand first the problem. So example, customers experience timeouts during checkout when flash sales occur. So you have flash sales. Sometimes you have sales that you want, okay, just buy in the next 3 hours, and you have a lot of people going there. And then we have timeouts. Of course, people start to guess what should be the problem, but sometimes it's very difficult to the root. So the root, we don't know, but we know the symptoms are the timeouts. What can we do about this? And this is a quite challenging one. Business drivers. So what are the strategic business goals? Why do we have our business? Okay, are there deadlines, market windows, or external pressures? Something that is always related with the business. What metrics does the business care about? So because at the end of the day, the management wants to know, okay, it's the number of sales, it's the revenue, okay, and what is the impact? We have this problem. What is the impact when you consider these metrics? So which goals are impacted by the problem? Okay, we want to sell more. That's the goal. We want to create a great image. Okay, are these image being we have having a bad image because of these issues? That's the business drivers that you want to understand. Example: revenue loss during sales events. Aim to capture 25 more sales in Q4. These are the business goals that we had, but we are having some revenue loss. So what are the business drivers? Usually the business drivers you can ask to your product owner, the manager, the business people. And that will be one of the most important things for you to take a decision of the architect, because maybe you don't have a good solution, but you can at least make sure that the business drivers are there. You don't have revenue lost, for instance, and the other, it depends, of course, of the other metrics that are defined. And then you have success metrics. So how will we know the problem is resolved? That's one of the most important things. And in some meetings, I'm always asking this. So how do we know that we achieve what we are discussing about? That's one of the things. So we are implementing this system. And how do we know it's enough? When should we stop? How do we know that it's resolved? It's timeouts that disappear. Can I test that? How do I know when I reach the success? Okay, that's one of the points. I remember a discussion of one guy where we're talking about how much money is enough. And sometimes it's very difficult for some, because people say, I want to be rich. You say, how much? When will we want to stop? You get 1 million, you will stop, or you try 2 million, 4 million, 5 million, and say, okay, I will try more. So when do you stop and you really enjoy your money? So it's again, when do you know your problem is solved? When do you know that you achieve the success that you want? There is a number for that. Can you measure that? Do you know when? And this is the most important thing. When you are resolving an issue, ask the people. Sometimes I ask the people, what behavior do you expect for you to say this is resolved? That's the question that you have to ask and have an answer. If people don't have an answer, maybe they don't have the problem. If they don't the answer to that, because when you are, if you have a pain, the problem is resolved when the pain is removed, right? You feel nice. That's one of the things. What does success look like technically and for the business? Define quantitative KPIs and qualitative sign-offs. For instance, 95% checkout requests should complete in 1.5 seconds under 10,000 users. That's a good measure. So you can do a test for this. You can measure the KPIs on your system, so metrics, and you can acknowledge that you reach the success metrics or not. So technical constraints, what are the non-negotiables? Service league agreements, legal, budget. This is sometimes you have data privacy. You are receiving data that is private and people want to remove it. You have to understand all these technical constraints. Maybe it's the people that you have. Maybe you have to buy from specific vendors because you have an agreement, you have a big discount. So you should use that database even if it's not the best for your solutions. Sometimes it happens. And as an architect, I'm sure that you know, if you are targeting to be an architect, that's one of the first things that you should know. It's not what you think technically it will be the best. You have always to consider technical constraints in the company, and most of these technical constraints are aligned with the stakeholders. From the management point of view, they have agreements with big companies. Which developers do you have? What are their knowledge? Which language they can dominate? Which tools they usually use? And these are the ones that you should use and try to fit on your solution, unless there is a big reason to not do so. And in that case, maybe you have to hire someone or make sure that you can change something in the mindset of your company. Is there a technical debt or architectural decision that limits us? Something like that. So solution must run on Azure. Team has no experience with Kubernetes. Imagine you want to put this in Kubernetes, there are a lot of microservices, and I go to Azure. But usually in Azure, you are not required to use Kubernetes, but when you have a lot of systems, maybe it's a good idea. But the problem is you don't have people for this. So it's a constraint that you should consider should I go to Azure or maybe I go in a different way? There are a lot of things that you should ask. But at the end of the day, you have this constraint. Team has no experience on this. So this can be a constraint. And maybe you have to hire someone at least to work alongside your DevOps people or operations people so they can participate and learn. And for a while, you hire for 3, 4, 5, 6 months. So they can do the best for your job. At the same time, they are training or coaching the people that you have that will remain in your company. Then you have the system forces, like what performance, scale, availability, or reliability force are acting on the system. You have to understand all of this from the metrics. What's the nature of traffic patterns? It's burst, steady, cycle. This is one of the first things that I always think when I'm designing architecture with users in mind. For instance, when using some systems like stores, probably depending on the country, people probably will buy more at night because during the day they are working. Maybe after dinner, they will go more to your store. But depends on the country. Of course, if you have a site that is worldwide, you have to consider all of this. But for instance, if you are developing an application that it's more internet, maybe you have bursts in the morning when the people enter because of the logins, when they go to lunch and before leaving, maybe they have to, let's say, write some time sheets and things like that, or they want to end some work and they push things to the Git. So there are patterns that you have to understand, traffic patterns, because it will be targeting not only the scale but the elasticity of the system. Sometimes you don't need, you just need on average, let's say 500 requests per minute, let's say like this. But at some points in time, maybe you need, let's say 10,000, because in the morning there are a lot of logins. How do you handle that? Do you have more machines, or do you need just machines for just a couple of minutes? And maybe that's one of the decisions, say, maybe I put this system in a cloud because it can be elastic. I pay more during these minutes, but then I will pay less because I need lesser machines here. So that's one of the things that you should understand. For instance, in this example, checkout API, it's tightly coupled with the payment service. During load spikes, let us increase 4 times because usually the payment service has to do a lot of verifications if you have credit cards and things like that. So you are doing a checkout, but he has to wait from the payment. And if you do the payment synchronously with the checkout, and the payment should go to credit card that connects to the bank, and you'll check, maybe they find issues, they require other information, and you have a bigger latency here. So maybe you want to think about, maybe I should put this more an event, a synchronous operation. So I can do the checkout, and later if there is a problem before confirming or finalizing the order, I can say, okay, there was a problem with the payment. Do you want to change it? And you can see that most of the websites, they do like this to avoid the big latency during the most important thing, that you want the people to buy something, address the payment later. Sometimes people buy, but they have to pay. It's the most important thing. Yeah, but it's from the marketing point of view and image point of view, you want the person to really want the order. Only later you will ask for the payment, because sooner or later the person will provide you a way to pay. Okay. Stakeholders and boundaries. The 6th point here: who are the decision makers? Of course, you have to understand them. You should understand with whom should you talk about any issue that will move forward your rational thinking about the solution for your problem. So you are the decision makers, influencers, and end users. This is really important. The end users, I told you an example, are end customers. From the public point of view, are internal users. So you have different perspectives on the system. So internal users, okay, it's bad, but it's not really bad for the image of your company. They are employers, they understand, but outside people, it's a completely different. So, and these will make the decisions completely different. Maybe you don't mind to have 1 or 2 or 3 days fixing a system, internal system, but from the outside, maybe you don't need, you need hours only, and maybe that can be a real issue. So who might be disrupted by change? What systems or teams does the architecture touch? What are the end of points? Contracts, single service level agreements, and things like that. So example, marketing team drives flash sales, but ops team gets no pre-warning or visibility. This is really important. So there should be, these two people should understand and work together somehow. So these guys are taking the decision, but they will influence the ops team, because they will have to handle probably more issues, more requests, and things like that. And they should be in advance warned about that. So even the team should prepare for that. Maybe they have 3 people. Now they need 4 or 5 people at specific days of the week or close to holidays to address an increased number of issues. And of course, you reach the solution hypothesis. What could solve the problem? Not the final design yet. I doubt that you have a solution on the first approach. Are there multiple candidate paths? Again, what assumptions can we validate cheaply? Mean that we have candidate paths, and just say, okay, but how can I validate this? Which one is the best? Sometimes it's not easy. You have an intuition, but you want to show. So can I put something on the system that can help me to take the decision? Maybe I can shadow some of the services, like the example I did before about you have a table and you have an event. Maybe I can shadow this and try, say, okay, it works better with this event. Maybe the 2 or 3 solutions that I'm thinking about, they use events, maybe it's the right approach. Maybe, okay, let's suppose that is the right approach. Now let's try another thing. Okay, it's helping that, so I'll create another component. Sometimes you have 3 or 4 solutions and you take the best parts of each one, and maybe there is a new solution that it's a kind of a composition of the other solution somehow. So you frame options like experiments or prototypes. That's really important. For instance, for the example that I was giving about latency and things like that and timeouts, it's not easy. Sometimes you have to test things. It's not easy to check this. And I've worked in a place that we took weeks, not because it was not technical feasible, but there are a lot of stakeholders involvement. It's a bank. It was really crazy. And there was some timeout, some files that we didn't understand, and it could fail on the firewall, it could fail on the network, it could fail on multi-threading, and the system was talking another one. It was very difficult. There were a lot of different layers, and we had to do a lot of experience and prototypes to understand where is the real issue so we can fix it. And we have to talk with everyone, networking people, operations people, developers, and so on. So that's this happens all the time. So using Redis-based queuing can smooth traffic spikes. Try and dev simulate load. That's one of the things. I'm saying Redis, but it could be a Kafka, can be a message queue. For example, queuing, because if you remember our problem is regarding timeouts, there is a coupling between the payment and the checkout, and maybe creating some asynchronous functionality can help the system. But it's a try, it's not a solution. It can be a solution. Okay, so let's see a real example now and move forward on it based on these 7 approaches. So you can see something real. This is quite complex. You can return to this later if you want, but it's just an example of something that get really complicated. So Those 5 steps I already give you examples, so I hope you understood them. You can review them, of course. You can go back on the video. This is a real one if you want to explore, or if you want to jump in, because I already understood. I can jump this and return to this later. That's okay, but I want to give you a real example and a complicated one. Okay, so there is a use case, a problem description. So we have these issues. There are some flash sales, as I was talking about, and 20% of the checkout requests fail or timeout. It's a lot. One-fifth of the requests fail. It's not a good thing. You go to the website and 1 in 5 clients is having issues. So issue began surfacing last Black Friday and was worsened with which major campaign. Clearly you will start to see a pattern here. There is an increase of the users, something is failing. Support center volume spikes, of course, the support people are complaining, at least 1 in 5 people. Most of the time, not all people send a message unless they really want the product. It's a good thing when someone complains. It means that they still want to be your customer. If you don't have complaints and system is failing, it's a really bad sign for your company. So, and engineering logs show no clear root cause. And that's something that it's not... unfortunately, it's something that happens. Sometimes we don't train the developers to create good loggings. Okay? Just slowdowns across multiple services. Impact revenue loss during key sales periods. Negative social media feedback affecting brand perception. And this is most important. You can see that you have technical things here, and you have on the side of impact, it's always about the business, the feedback, negative social media, brand perception, and things like that. And as an architect, you have to understand what here is a technical issue, but for you to address this technical issue, you have to understand the impact on the business side, because you want the business people to be happy because they are paying and patrocinate the project, right? Don't forget that. So let's start. This, of course, is the first step, the description of the problem. Let's see the business drivers here. So flash sales, these are values are not really relevant, but I just want to give you some, let's say, somehow real data. So flash sales are critical to quarterly revenue, meaning that the company earns 35% of money with the flash sales. So it's quite important for the company. And you have to understand how to read this. Because when you are an architect, when you go to the meeting, you want to, when you talk to the business people, to want to make clear that you understand that it's a lot of money, and there is a big impact on the revenue of the company if you don't resolve this. So you, let's say you show them clearly that I understand your problem. I understand that you have 35% increase in revenue, and with this problem it can be a big issue. So we are really committed to resolve this. Marketing plans to double flash events in 6 months. Okay, it's something that they are planning to do. And customer churn time to bad checkout experience, meaning the customers are leaving your company. It's not a good idea. It's not something good. You start to see that the number of customers reducing. And how do you know? It's not they unregistered from your website, but they don't buy anymore. You usually have some metrics that show the average checkouts and things like that, and you see that they are reducing the number of checkouts. If you compare with the number of customers, you start to understand that there are fewer customers now doing checkouts, which is a problem. And executive directive, and of course this is always important, no failures tolerated during holiday sales. So they want a system that is reliable. Who doesn't, right? So key metrics tied to the business: sales conversion during events, customer satisfaction score. I see this a lot on the companies. And usually when we have these town halls and things like that, they always present these nice charts and say, what is the customer satisfaction score? And not sometimes it's not the end customer. Sometimes the customers are other companies, and you want to understand if they are satisfied and how much from 1 to 5. What is the trend? Okay, and the page abandonment rate, meaning they start to do checkout and at some point they just left. Maybe there was a timeout. They say, okay, I will buy in another place, and you want to check this data. So use cases, success metrics. It's the third step. 95% of checkouts complete under 1.5 seconds with 20,000 concurrent users. That's what for you it's the success. And of course, this is should be talked with the metrics that you have with business people. Remember that most of your decisions will be with business people. It's not that you think you know. Ask it. It's business. It's not architecture thing. It's business thing. Always ask them. Every time when I am in meetings, I talk with developers and other teams, and sometimes I ask, what should I do this? And say, Go to the product owner and ask it. Go to the business analyst and ask it. You don't know and I don't know. I'm not managing the company. I'm managing the solutions to accomplish the objectives of the company. So they manage the company and I make sure that the IT supports that. That's it. I don't know. I can have an idea. I understand the business, but I don't know what are the real numbers unless they say to me. And if they say to me, I will use them to say to you. But you have to ask. So these numbers, always ask them, always, and teach your teams to do the same. So error rate below 0.5 per order during flash events. System auto-scaling should respond in less than 30 seconds. Maybe you want something like Kubernetes here. And you have post-sale support tickets for failed checkouts reduced by 90%. Okay, that's you really want a system that is reliable. These are the success metrics, meaning that your solution should address all of these, should provide a solution that can handle all of these numbers, and you should have a way, don't forget this, to measure this, because you want to show that you address all these success metrics. This is really important. Remember, one of the most important things, it's what is your success? What is the success? How do you measure it? When do you know that enough is enough? That's the point. And this is really important, not only in IT, even everything in life. You should understand where do you want to go and when do you reach it. When do you reach it? Now you can think about another step. And this applies to everything, and IT, it's not an exception. These are quantitative. Now you have qualitative ones: marketing reports, confidence in system stability, and support teams not flooded with incident escalations. That was one of the issues that we were talking about earlier. The fourth step is technical constraints. So I want to create a solution, but what should I take into consideration that can be a problem as an architect? First, all services must run within Azure environment. Do I have people for this? Do I have to train people for this? Azure contains all the database and all the components that I need. Is my subscription handle this? My business subscription? There is from the FinOps team. Do I have a limitation on something that I can for the expenses? Maybe I have to choose a database over as Kafka, because Kafka is more expensive than the database, for instance, like that. And I know what I'm talking about, because in some of the projects, sometimes I use a database rather than tables, rather than events, because they are more expensive and the company is starting and they don't want to expend money on that. So I design a solution that, okay, I'll start with the table and later it will be easy somehow for me to move to an event source. Maybe I use events using tables. And it's possible you will create a cron job that goes to the table, takes the rows and mark them as processed, things like that. They move to another place. Sometimes it's one of the technical constraints. Operations team is short-staffed, limited tolerance for new stack complexity. It's if the system grows, usually, okay, I'm jumping. So the system grows, and yeah, sometimes we think that the guy can do everything. No, he can't. It's just a person there, or 2 persons, or 3 persons, and he has to handle all the new things. If they were receiving 100 requests per day, now they'll receive 200 or 1000 per day. Unless we resolve things, maybe of course they can optimize, and they should have a strategy on their side also, and align with the business and the architect to make sure that we can facilitate their life. But they, of course, the system grows, they should grow also somehow. Legacy payment service cannot scale horizontally and must remain until Q4. This is a real constraint. This can be a real concept. Maybe it's like that we need to improve the payment system, but we have to find a solution around the service. We cannot touch the service. So we have to work around to resolve the problem. And yeah, there are a lot of patterns for this that I will talk about them in future videos. But yeah, it's a constraint, and a real constraint. And in the bank companies, assurance and things like that, we have a lot of this. Because they don't want to touch some of the systems. They have agreements with companies. They pay millions in here. So they don't want to change until they really, they have to, let's say like this. And they have people, they are training for that. They need time. And time usually it's sometimes around 1 year. 1 year. And I'm not exaggerating here, unfortunately. And budget capped at 10K amount for additional infra, meaning that we can only spend this per month on if you want to additional infra, if you want to put the database. It seems a big number, but it's not. If you have millions of rows in one database, you reach this value really, really fast. It's not nothing special here. So system forces, flash sales result in traffic spikes from 2 to 20. So our system needs elasticity in 10 minutes. So we have to find systems that can scale horizontally probably, or vertical, or both at the same time quite fast. Checkout service calls inventory, user session, payment, and shipping. Okay, these are the connections between the systems, and there will be performance here impacts and reliability, because there are a lot of connections with external systems here. So we have to understand if for one of them, what are let's say how deep are their relations, or how tight are their relations. Is the inventory can only go after the session, after the payment, after the shipping? They can work, or can I find a solution that all of them work asynchronously? And it's something that we should create a diagram here and explore the relations between them and understand what should be sync, what can be async, what will be the impact, what do we lose, what do we gain, and things like that. Maybe we gain time, but we lose reliability, or maybe at the end of the checkout, we have to wait 5 more seconds to receive an answer from a system, and things like that. Payment service adds latency and can't handle retries well. Okay, this is a call to action here. Deployment model doesn't support rolling updates during high traffic. Okay, it's operations here, but it can be a thing. Maybe we have to think about to modularize our system to understand if we have to deploy everything, or maybe we can just deploy parts of the system. And that's one of the reasons that people like microservices. In microservices, it's easier to deploy, because you can, if you have the microservices async with each other, and they are not tightly coupled with each other, it should be somehow easy for you to replace one of them with another. And you can incrementally deploy the system. It's not that it's a good solution, but in some cases, it is the solution that you should have. Okay. Observed, the probability in 99 latency increase linearly under concurrent load, meaning that you have a big spike that 90%, 99% of the time you have somehow good performance, but then the latest 1% that starts to be really slow. And that's the problem. This will be the customers that can be an issue. And today, with social networking, Twitter and things like that, you don't want 1% of your customers complaining about your website or your service, whatever it is. And cache miss rate during sales increased three times, meaning that you have a cache that can increase the performance of your system, but if you have a cache miss rate, meaning that most of the time that it goes to the cache, the item is not there, should go to the real system. So the system will start to degrade. So maybe you should start somewhere here and check, okay, what can I do with the cache? Maybe people, they go to a lot of different products and the cache at first doesn't have all these products. Maybe I can warm the cache, meaning I can pre-fill the cache with some data. And of course, you have the stakeholders and boundaries. Marketing needs predictable success to meet campaign goals. Support gets overwhelmed during flash sales failures, everything that we're saying. Now, the finance monitors lost order and then burnout cards, and you don't want the finance people in your meetings complaining, because remember that companies exist to earn money. So operations, minimal changes during critical events, risk averse. And engineering wants observability improvements and deployment resilience. And I would say in a system like this, observability is quite important. Today, every time I design a system, one of the first things that I do is that, okay, how can I integrate observability? Meaning reading logs, metrics, traits, and things like that. If you want to know more about this, I'm creating a series about observability that you can see on my channel. So systems involved, web front-end, checkout service, inventory, payment gateway, and Redis cache or other kind of mechanism, but Redis cache is probably the most popular one. So candidate ideas. One is to, let's say, decouple payment call from synchronous checkout using outbox pattern. If you remember, one of the issues that you have is that when you do checkout, he has to wait from the payment. And maybe you want to reduce, but that sometimes the payment, it's really important. It doesn't make sense to do a checkout and accept an order until the end without the confirmation of the payment. For that, you can follow, for instance, something like outbox pattern. Usually I create specific videos for the patterns, but here I explain to you this pattern in case you don't know it. So the main idea of the outbox pattern and the 30 seconds, imagine you have a service one, let's say it's our checkout, this one here, and you have this service two, which will be the payment. And Sorry for that. So you receive a trigger to start the checkout, and you write the information about checkout in the real table. But since there are some problems when you are connecting to the payment, you want to make sure that these problems don't get back to the application layer. So you write to a table alongside the real table, which is called outbox table, and that's the name of outbox pattern, meaning that you put information here and you create here like as if it was an event that you want to put an event. But since the event was failing and you cannot be sure that it works all the time, you put on this table. Then asynchronously, you have a publisher here that will go to this table, because usual databases are more reliable to be up if the database goes down or your system goes down. So the outbox will not be an issue here. So if the real table is online, the outbox table is online. So you go there, these, and see which events that are in this table are not processed. So you take them and you try to put them on an event queue. And if something fails, you can warn something, notify someone, say, there is an issue here. But the data, it's here. And it should sooner or later will be delivered to this consumer. It's a kind of assurance that your event will not be lost here. Otherwise, if you try to write an event queue and fails, maybe you don't want to insert data on the real table because you cannot connect the checkout with the payment, and that will be a problem. That's one of the reasons to exist this outbox pattern. That's one of the ideas that can improve the issues, the latency and things like that that we had on our system between the checkout and the payment. We can introduce also Redis queue for checkout throttling underload. That's another solution, creating queues. Like if you are using Redis for cache, why not using for queues rather than use the outbox pattern? That's another way. Add lightweight health indicators to drive predictive auto-scaling with some indicators to check how well is the service. For instance, it's up or now and you can do something about it. And uses feature flags to progressively roll out change during campaigns. Feature flags, it's quite nice. Sometimes people associate feature flags like saying, okay, I have an option database. If it's one, this feature is active. If it's not inactive. But sometimes it's not the feature. Maybe the system is heavy loaded and you want to disable things on your system to make it more smooth. Or other times you just add features, okay, and that you were supposed to put it later, but you start to rolling them like this, meaning that you find a way to develop your system without, let's say, deploy your system, you activate things that are there, something like that. Okay, so use feature flags to progressively roll out changes during campaigns. That's, you can see both days. Usually in this case of scenarios, I would say that you want to disable things with feature flags because they have an impact on your solution. And I know that some sites do that. When there is a big increase of the users, some of the ads and some of the features that are less used are just hidden, so the site will render faster and the reliability will increase because there is less complication on the system. This is something for you to consider. That's why we call them candidate ideas. Then, of course, you need some cheap validations that should be fast, but let's say enough for us to understand and take the right decision. So simulate traffic in staging with news retry queue logic, for instance, using this outbox or other solution. Okay, measure cache performance and implement pre-warming on sales start. Pre-warming, it's you can fill the cache. It's something that I always do in some specific, when I have products, for instance, usually I create a cache and I put all, at least, let's say 80%, depend on the number of products, of course, but maybe 80% of the products that I know that there is a high probability to being sold on the cache. So I will reduce the cache hit on it. So, and shadow outbox pattern on production without disrupting flow, meaning the idea is implement this alongside the current solution, but you don't use the real services, meaning that when you write this at the same time you write outbox, but this one is just a simulation. It exists there, but the service to it is not the real one. You just want to check what happens if you are using this solution. That's why we use the word shadow. And if it works okay, maybe it can be a great solution. So shadow outbox pattern. Unexpected results, reduce peak pressure on payment system, smoother auto-scaling, and stability and speed improvements during spikes. I hope you are understanding all these solutions. You can always, of course, go back and try to understand this. I'm giving a lot of information. Maybe this video, it's should be more videos, but I want to explain this framing and how you can take a decision. These videos are long, by the way, because it's architecture. There's a lot of discussion. It's a kind of a mindset more than formulas. If you are trying to be an architect using a cookbook, you'll never be an architect. Just be a guy that knows things, and at some specific points in time you get right, but most of the time probably you will get wrong, because you have to understand all of these dimensions when you are thinking about solutions. So use case, a final frame strategy. Phase 1, implement retriable queue with outputs pattern. So we did all these tries, you get the shadow outputs pattern, and you say, okay, let's use a retriable queue with outputs pattern. Shift payments to async and validate vlogs regarding outputs pattern. Now the payment will be async. It will let's say checkout will not depend on the payment. The payment can be delayed to the end, but it will be the phase 2. On the phase 3, add auto-scaling health signals, warm cache on sales start. That will be the third phase, and monitor KPIs and interact with stage release. You can see this is an incremental approach. You don't want to implement all of this same time. Start with the phase 1. It will be just a small impact, but you can start to see some difference. For instance, probably you will see your system to be more smooth without those timeouts. Then you will see a faster system because you are in a sync and you can validate vlogs, so increase the logs. Then when everything is working, now you do some add some auto scaling health signals, and you arm the cache, and now you are resolving the cache miss, or that we talked earlier. If you see, these points are all the ones that we address before, and monitor KPIs and iterate with staged release. So the stakeholders all align. So you have to, if you remember, we had to talk with the ops, we had to talk with the financial, we had to talk with the marketing team, and so on and so on. And trade-offs considered. We considered all the trade-offs. That's why we took these phases here. And risks explored early. For instance, the outbox pattern was implemented because we couldn't change the payment system. If you remember, it was a legacy one. So we didn't change the payment system. We just changed around it to make sure that we avoided all the timeouts. So the risks were explored earlier, and strategy builds confidence and reduce uncertainty. So everyone understands what's happening, because you can explain all these phases from all the points that we saw here on this framework. Okay. Now this is just a diagram. If you want to pause here, that summarize everything that we do, the phase 1, phase 2, phase 3, phase 4, you can see the first one, it's retriable queue, and the checkout failures between 15 and 20%. So we use the outputs pattern, reliable queuing, and we start to see begin some reducing failures. So we have a reliable checkout, prevent lost sales, and minimize retry effort. You can see what happens for the second phase, the third phase, if you want to pause and read it. And finally, monitoring and feedback. We have a lack of clear root cause in logs, so track KPIs, gradual rollout, enable iterative release, improve visibility and control. If you remember the iterative release, we start to wonder about use of feature flags and things like that. So we have continuous improvement with observability. Again, we should have KPIs, metrics, traits, and things like that, and low risk changes. And the outcome will be confidence and low failure rate, better customer experience. Everyone a win-win here. The company wants it, the customer wants it. Higher revenue in sales. Of course, people return there. It's fast, the system is reliable. I can put my money there without feeling something is wrong. And fewer complaints plus tickets. Use case, if you want more smaller ones or quick answers, not this big one, but it's more about what we talk about, but in a fast way. So let's say you have some kind of to decide about microservices. We need microservices. Let's frame it in a very simple way, just a simple way to do it. Business call, faster deploys across teams. Yes, that's one of the things about microservices. Constraint, only 3 devs, monolith works fine. You have only 3 devs, you don't have 3 teams. So microservices is not a solution. I can assure you that. I think I addressed this also in a video about decision frameworks. The first one, I think it's first principles. I remember to talk about this. And you want to be true about your company, and you only have 3 devs. You don't want microservices. It will be crazy for management, okay? Alternative solution, modular monolith with bounded code. So you create a kind of, you follow the philosophy of microservices, but with just one application which should be understood by the 3 developers. They work on the same code, they can talk, they can share ideas, they understand all the code. If for instance, one goes on holidays, the other 2 can understand. In microservice will be really difficult. And outcome, lower complexity, same agility, goal achieved. Sometimes it's not because it's the trend. we want to use Kafka because Kafka, it's a trend. We don't want to use now tables or message queues. We need Kafka for events. Volume that we have 1000 events per day. You don't need Kafka for this. Need retry plus the couple billing, simple solution usually Postgres with outbox pattern and the retry job. If you saw my outbox pattern, you understand why you don't need Kafka. A table should be enough. It's per day. It's not per minute. If it was per minute, maybe you should think wisely about using Kafka, but per day, that's a good. You can use it, but it's too much probably. And remember that you have to understand how this works. You have to people to understand this, how to mount it, to architecture, to troubleshoot, to install, to configure, to know the best patterns, and so on and so on and so on. If you start to think all these things, at some point you say it's not about using Kafka, it's about supporting the Kafka after it is installed. So add Kafka later when justified. Now it's cloud migration. This is quite popular nowadays. Let's migrate to AWS. Maybe it can be a good solution or not. Problem, current infrastructure takes days to provisioning and often results in unpredictable downtime during scaling. That's one of the problems, and we know that in the cloud we don't have these issues. Constraints must comply with PCI DSS, which is a payment industry regulations. Data must remain within specific geographic regions. That's something, and there are several of them in the world. I think 6 probably. I know GDPR. There was the California Act. There is the Brazilian one, China one, Asia probably, Australia. By heart, I remember at least 5 of them, which means that the data of these countries should be in these places. You cannot put European data, for instance, in Brazil. Things like that, or the Brazil be on Europe without authorization. So you have to create multiple clouds, let's say, region. You have these configurations in the cloud, but you have to have someone to understand this really well, even from the legal point of view. So limited cloud experience among ops team, that's an issue. Maybe you want to train them, but you have to justify if you really go with the cloud or not. Goal, reduce provisioning time from days to minutes and improve cost and spread. That's your goal. Let's explore some solutions. Is cloud the only way to achieve elasticity and speed? If it is, okay, it's a big favor point. Can we improve provisioning on premise first and then later think about the cloud? What specific workloads benefit most from the cloud? Okay, outcome, phase 1, use Terraform to automate existing infrastructure to reduce manual ops. So if you use Terraform, you can automate most of the things from the operations point of view. You can identify low-risk workloads like reporting, batch processing to migrate first. But okay, we'll migrate to the cloud, but let's start with something that doesn't have a real impact on the customers. Something that can take days. Even if it fails, that's no problem. If you don't receive report in the morning, you can receive it later and you fix the issues and you can improve the system. And at the same time, we gain some experience, okay? Build a compliance strategy with legal and risks team before full migration. The legal, because of the data, it's always important. And architect's insight. As an architect, cloud is the binary choice. If you are an architect, don't think it's, I should go cloud or not. Maybe you can do both. Don't think about this. There is a trend in the world sometimes when people say you are pro or in favor of something. It's like you have just 2 colors. No, you have a lot of colors. So I remember someone once said that, okay, there's a kind of politicians that say, do you want a garden here or a shopping mall? And some people say, I want a school. But when you address the question with only 2 options, people forget that there are other options there. So don't forget that. At cloud, it's the same. It's not go cloud or no cloud. Maybe I can have both. I can have premises and cloud for other systems. So strategic phasing avoids disruption and builds team maturity. Maybe you need time to get maturity and then you go there if you think it's wise. Okay. Use case, machine learning adoption pressure, add AI to improve user experience. Sometimes users drop off after the first use. Root cause confusion onboarding people. Okay, let's use artificial intelligence. But sometimes you just call a great designer, a guy that is good in design, and do some analytics, they do some tests, A/B or something like that. And probably even without machine learning, with just a new design, you can change completely the experience of the website. Architect's toolkit for framing, event storming. There are some things that you can help you to implement all this framing. One, it's event storming. It's a technique to discover domain process and hidden complexities by collaboratively modeling events. It's a kind of, you can see on the internet, there is a kind of a trend on this. So you gather all the people and you start to understand all the events from the business point of view. So people understand the events that happens in the company and brings all the kind of awareness to everyone and makes them create better decisions and better solutions because they understand everything that can happen. on the company. So the benefits surface misunderstandings early, promotes shared understanding across tech and no tech roles. Then you have the C4 model or on any other. I usually like to create my diagrams using things like Mermaid, Plan2ML, C4 and things like that. You can create diagrams with this rather than use other kind of tools. And usually it's quite nice. Of course, C4 model, it's only about that. There is tools to use this. It's about how to model this. And usually this is approach is a great approach for you to understand the context, the container component code, because it's the way this C4 model works. Of course, you can apply C4 model with other these technologies with, let's say, diagram as a code. Usually I associate both because I use both. But this is it's quite common in architecture to use this for C4 model. Usually most companies, most of the times I just use, let's say, not a great formal system, but when I want to go formal, I work before with Archimate, and Archimate is really good to define things. But sometimes it's not easy for people that don't know Archimate to understand the diagrams, but it's really good from the semantic point of view. And when you want to merge the business part with the technical part. Okay, but C4, it's another way. Problem solution interviewing meant the purpose, conduct structured interviews to deeply understand user pain. And this is one of the most important ones that you want to address business problems and success conditions. Okay, and benefit avoids premature tech decisions, ground design in real user context. Okay, as interview, it's quite, I remember that I cannot give the details because of the agreements that I do with companies. Most of the companies, before some of the solutions, you create a lot of surveys. We hire companies to survey users that we think will be the target of our product, to understand them before taking some decisions. Then you have this Wordley mapping. You can read about, I think there are courses and books. There is, I think it's something created by a guy called Simon Wordley, and can help you to understand. It starts with to give you, let's say, 15 seconds about this. I don't want to teach, maybe I will present one video just about this because it appears in some of my slides. Usually you have this the target people, and then you have the what are their needs. How do you address their needs? And then you start to draw some box and say, I'm creating a website for them. I create this, and then to create this website I need this, and then you have a kind of a layers of this about the context and things like that. That you say, okay, which one of these needs will be addressed in this way using this kind of a phases. I'm stretching too much. I don't want to go into details, but at the end of the day, it's the maps technology capabilities and components by maturity and the strategic value to anticipate evolution and avoid building the wrong thing. That's the definition. But at the end of the day, it takes into consideration what are the target population that I want and how can they benefit, how can I align technical roadmap with my business strategy, meaning that I want to make sure that my audience will like my solution and highlights when to build versus buy. There are a lot of things, decisions they could take on this. I just explored a few ones, but if you want to read it, it's nice to understand this. If you want, you can wait. I don't promise when I will create this, maybe in the next weeks. I'm sure it will not be on the following days. I already have my to-do list of the videos, but Wordley mapping appears a lot when we are talking about business. It's not that you go to a company and say, let's do a Wordley mapping, but usually you can propose to do an exercise and you can use this without using the name, and it will help you. You just go to the website. They have a tutorial of 90 seconds and that can explain you this quite well. Trade-off matrix analysis. Trade-offs, it's about architecture, systematically compare architectural options using constraints and success metrics. That's what we talk about in this video. And stakeholder interviews, again, capture expectation, pain points, fears, success criteria. Always ask to stakeholders. If you want to, the most success is about communication and understand what is the pain, and then take decision. Then you have constraints, and within these constraints, get the best solution, confirm again with stakeholders, and then put it in practice. 20 patterns to watch. Tool worship ignores context. People are just, I am a JavaScript guy. I'm a Kafka guy. That's not the approach. That's the tool worship. Copycat architecture. Okay, usually we use microservices with success. It doesn't mean that your next solution architect should use the same architecture style. One size fits all. Every problem is unique. It's very related with the previous one. Every problem should be understood as this problem. We don't have to compare with other ones. Ignoring trade-offs, that's a big mistake, leads to brittle systems. When you choose something, you are losing something. Remember, maybe you are creating a technical debt, address that, write that, create, for instance, something that it's called architect decision record, something I talked in the past, and document why you took that decision and what did you lost when you took that decision. Premature optimization, don't optimize the system at first. Wait for it, do tests, optimize later. It's not a good idea because you don't know how the system will behave and you don't know clearly will be the users, how they use your system, things like that. Over engineering, don't, let's say, there is a principle that says Yagni, you ain't gonna need it. If you don't need it, don't develop it. It is as simple as that. Anchoring on past success, all solutions may not fit in your context. It's the same like this, every problem is unique, it's the same thing. Address each problem as the first time that there is a problem. Don't compare with other ones. Avoid stakeholder input, miss critical constraints, never. And if you listen careful to this video, it's all about stakeholders. Listen to them, confirm with them, get their approval and do something. And all of them, internal company and customers with surveys and things like that. Fear of saying no leads to unclear scope and misalignment. No, it's the most important one for progress. It's not yes. Yes, it's quite easy to say. But the problem, and I see this a lot, people, they say too much yes, then they get really tired and they can start to go against the company because they didn't have the courage first to say no. Say no, it's a mature thing. You say no and they explain why. And people understand, okay, this guy knows what he's talking about or she's talking about. Okay, he say no because of this and this and this. And I understand his point of view. Maybe I will, let's say, relax here somehow. What I want, maybe I wait for something. Maybe we shouldn't go this way because he is reasoning well. So if you think it's no, say no. And every time I said no in the past, I was really successful in the job. People start to consider me a kind of a person to listen for because I was concerned about their business. It's not always saying yes. It's easy to say yes. Okay? Have courage. Stakeholder agreement on problem, measuring good problem framing, define success metrics, option list before tech solution, clear trade-off documentation. At the end of the day, to measure a good problem framing, ask if this problem disappeared tomorrow, what would change? That's a question that you should ask. And you know that if you did a good job or not on your problem framing. So learn to think like an architect. This is a kind of a series that I'm doing. Practice problem framing weekly. Try to understand every time you are in a meeting, say, let's see if I can frame this and consider all these points. Shadow stakeholder meetings. Okay, shadow, understand what's happening, what they are saying. Create impact maps. Try to design things. It makes you a better system thinking. You start to visualize how the system works, and then you can optimize the system. You can detect bottlenecks, you can detect improvements, and so on and so on. Run retrospectives around why was this built. And this is probably I'm sometimes a kind of a guy that people don't like in the meetings because I'm always why. And people, you should go this and why. And they say, okay, because of this and this and this. And what was the alternative? I'm always asking this, but people, after some time, they start to understand why you ask these things and start to respect you. And before they talk, they already provide you the why. So they are starting with the why, and they understand why the why is important. Okay? From engineering to architect, system thinking, practice impact diagrams. System thinking is a skill that you should have. I'm creating videos about system thinking, and I will improve more videos about this because it's one of the most important things for architecture. Communication, lead discovery sessions, trade-off management, run design reviews, framing problems, document decision records. When you write, you start to think that someone will read, and you'll be more precise, and you frame better the problem because you say, okay, I'm doing too much, I'm putting too much, maybe I have to frame this, I have to narrow the scope. Maybe I can only do this. When you write, it's completely different than when you talk. Long-term payoff, durable, maintainable systems, respect from stakeholders. If you follow these guidelines, trust the decision-making because you understand why you took your decisions, and you start to have some strategic influence because people start to understand that you are doing the best for their business. So architects win by making others win. So in recap, architects solve the right problem, not the problems. Tools serve the solution, doesn't define them. Framing is not a step, it's a mindset. As we saw, use frameworks to clarify, not complicate. These frameworks that I'm presenting here, these videos, it's to clarify, to you have a plan, and you this one is about the metrics, this is success, this is stakeholders, this is the solution I'm proposing, these are the business drivers, this is the forces around the project and things like that. Okay, so thank you for watching this video, and I like to drop here this sentence: think deeply, and it's one of the jobs of the architect. That's why they pay you. Frame wisely, and the wisely, it's the word here. Okay, frame wisely. Being wise is not being intelligent. It's not knowing stuff. It's to take the best decision. And you need guidance. You need a framework. You need steps. You need to check all the dimensions and all the angles that from all the information that you have. And of course, architect intentionally, so you do understand why you are taking some decisions. Okay, this was a long video, more than 1 hour, but I think it's a really important video. This is about architecture. I cannot explain this in 15 minutes. I have doubts that anyone can explain this quite well in 15 minutes. I like to talk a lot. I like to give examples. I like to provide you the mindset. That's why I create timestamps. You can jump over them. But if you reach here after 1 hour, thank you for to follow through the end. And I think I'm sure that you learned something from this. Even when I'm developing these videos, I learned something. So I hope this series is great for you, are useful for you, and are improving your professional life. And you are, it's let's say, moving you towards your goal to be an architect, or maybe improving your already role as an architect. So thank you for watching, and I hope you continue to see my videos.